the nature of the electric force, also known as Coulomb's law. So Coulomb's law can be understood by describing what you see in this picture. So here you have a rod suspended by a string, and one side of this rod we have a material with more negatively charged, and on the side we have a material with more positively charged. Then if a second rod terminal, which is negatively charged, approach this rod is going to move, like having sort of a circular motion towards or away from the second rod. So in this case, on purpose, this terminal of this second rod is negatively charged, and we are going to call this charge Q2 because Q represents a charge, is the symbol for charge. And let's call this one Q1, which is the charge of this rod. So the idea is there is a force of attraction between both charges because they are opposite charge. One is positive, one is negative. So there is a force from the first charge towards the second one, a force of attraction, and also a force of attraction between Q2 and Q1. And let's say that these two charges, they are away from each other with a distance of r. R probably was considered the symbol for distance because the circular motion, and maybe that will be the r is the distance, the radial distance. But anyway, we have here a before and after situation. So before, if those two charges has the distance r, so we separate now, we place away from each other with a greater distance. We can observe that the force by intuition will be less than for this situation. So for this reason, was conclude that a force, the force of attraction between those two charges is proportional to the product of those two charges and is also proportional to the inverse of a distance between both charges. But what Coulomb, the scientist that was studying all this, he observed that the distance followed the inverse square law. So when we have the same variable that is proportional to two different things, we can combine those as a multiplication between all those factors. Multiplication between this Q1 times Q2 times the inverse of the square of the distance. Now was introduced a constant K, which is Coulomb's constant, is a factor that is the same, which is 9 times 10 to the 9. Actually is 8.99, but for my class I round to 9 to make it easier the calculation and make it easier for students to remember. So the Coulomb's constant, okay, is 9 times 10 to the 9, and the unit is newtons times meter square over Coulomb square. So this F that we are talking about here, forces that have all different nature, but this particular one that is produced by two charges is called the electric force. And also, like any other force, the unit is in newtons, or uppercase N for abbreviation. Q1 and Q2 represent the charges in coulombs, or as a symbol, uppercase C. And R is a distance between both charges, and the unit is meter. So the final formula for electric force is F is equal K, the constant, times the product of both charges over the distance between both charges square. So that is the electric force. Application of Coulomb's law, problem number 13. The force between two charges is 1000 newtons. One has a charge of 2 times 10 to the minus 5 coulomb, and the other has a charge of 5 times 10 to the minus 6 coulomb. What is the distance between them? So first let me draw a data table, and we are going to organize all our data in this table. So the force that it's talking about is the electric force. That's the nature of this force, is 1000 newtons. One charge I'm gonna call Q1 is 2 times 10 to the minus 5 coulomb. The second charge is Q2, 5 times 10 to the minus 6 coulomb, and is asking the distance between both charges. So the electric force, or Coulomb's law for force, is the Coulomb constant, K, times the product of both charges over the square of the distance between both charges. So I know that my F, the force, is 1000. K is Coulomb's constant, is 9 times 10 to the 9. Actually, let me write here, K is 9 times 10 to the 9 Newton meter square over Coulomb square. So the data table is important that you look all the units if they are all aligned with the SI units. And you do not want to substitute the values with the units in the formula. Get too long. All right, so here we have our K. Our Q1 is 2 times 10 to the minus 5. Our Q2 is 5 times 10 to the minus 6. The distance is what it's looking for. So first we are going to solve the product of all these numbers. So let's use this calculator. And it's very simple. So 9 times 10 to the 9. 9 EE 9. Now you multiply times 2 EE negative 5 times 5 EE negative 6. So we have, as a result, 1000 is equal 0.9 over R squared. So now we are going to do like a cross multiplication here. So we have 1000 R squared is equal 0.9. So R squared is 0.9. So you divide both terms by 1000. So R squared is So I already have my answer here. 0.9 divided by 1,000 is 0.0009. Now we are going to do a square root of this. So R is equal. So the square root is right here on this key. So press is 0.03 meters. So that's the distance between both charges when a force of 1,000 newtons is acting between them.